I think one of the most interesting things we've seen over the past few days is that everyone here speaks slightly different languages. What this project proposes to do is to figure out how we're all going to communicate, both as researchers and with our software. So we can start thinking about all the different regimes that really go into nanoscience. Things like small molecules, things like proteins, like nanoparticles and surfaces. And that we have a lot of researchers here who focus on slightly different parts of each one of these problems and oftentimes have overlaps between these different problems. And as we start to look out at the implications of their work and where the people they're talking to and the research they're connecting to in the broader world, we can start looking several overlaps through to much bigger concepts like DNA origami or how cells work, and on and on and on. And the question is, how do we have file formats that let us easily look at all of these systems in the level of representation that a given researcher actually wants to look at, but without losing all the data that the people looking at the smallest scales want to look at too? And then, what we're really here to do is figure out, and then how do we make this all accessible to people doing AI and learning? And how do we make it readable by both the AI software and the practitioners? So our proposal is to build a common language for computational nanoscience. This would involve an ecosystem of well-defined, unambiguous file formats, one that's readable by scientists from different domains, both by themselves and with their software packages. And I think most importantly, one that is readable by AI software and understandable and parsable by AI researchers. So I'm going to zoom in real quickly and look at one of the overlaps that comes up in this field a lot, which is the overlap between small molecules and then biological proteins. And the problem here is that the data formats we have now aren't extensible, they're unlinkable. Most of them come from these ancient Fortran codes that are expected to be parsed with fixed width, and many of them were defined by a grad student many years ago and actually have difficulties in terms of interpreting the data unambiguously. So I'm going to actually jump right over and show you how we're thinking about solving this problem with an already existing collaboration. So first, I'm going to run a very quick quantum chemistry calculation here. And you're already going to start seeing data in a few different ways. Got a two-dimensional chemical graph, a three-dimensional representation, and I just did some quantum chemistry, so there's also a bunch of molecular orbital information here. And there's also a ton, really a lot of the most important data here is numerical, and so we have lots of, say we have the overlap matrix, which corresponds to just a huge, here, 70 by 70 array of float numbers. And the question is, so how do I store this in a way that someone who wants to look at it in 2D can look at it, someone who wants the numbers can look at it, someone who wants to look at orbitals can look at it? And let me show you some of the current file formats. Mol2, you're going to have to write a parser for that. That doesn't look like XML or JSON. It's got a lot of information, but certainly nothing quantum chemical. Let's look at the PDB format, which doesn't store bond orders and does a fairly lousy job of describing atoms. And you can go even to something like XYZ, which I like because at least it's unambiguous. It's a list of atoms and their XYZ coordinates. But there's nothing here that stores the data that we need to communicate with each other. So what we're proposing to do is start looking into modern hierarchical data storage. Things like JSON that stores all of this, stores the molecular topology, stores its name, stores its provenance, tells us where it came from, and stores all the numerical data that certain researchers might need. Things like the calculated electronic wave function, all of the orbitals and their overlap matrix, and all of this in an easy to parse manner. We can And
existing collaboration.
Yes, we have an existing collaboration. This is our goal, file formats that cover this space.